Hello, in this video, I'm going to go over these problems from Module 6. Number 1, verify the following identity. You must show your work. So pause the video, try on your own. Okay. So the general rule is that, or general suggestion is that try from more complicated side and try to match the left side with the right side in this case, since left side appears to be more complicated. So pause the video, try on your own, and come back. So cosecant is same as 1 over sine theta. Multiply cosine theta. This is essentially 1 cosine theta over 1, which is cosine theta over sine theta. And cosine theta over sine theta is cotangent. So we just verified it. Okay? Because sine over cosine, side note, tangent theta is same as sine theta over cosine theta, right? And 1 over tangent will give us cotangent theta. Okay. So that means that if we do this 1 over this, which is cosine theta over tangent, it's cosine theta over sine theta. So that's why cosine theta over sine theta is same as cotangent theta. So let's look at second one. Again, pause the video, try on your own. If you struggle, that's a part of it. These you have to do a lot of trial and error to build the intuition of verifying. So this is more complicated side. So let's try. Okay, so if you try on your own, so let's see. So tangent, let's rewrite tangent as sine theta over cosine theta plus cotangent is cosine over sine theta. Cosine theta over sine theta. Entire thing over secant is same thing as 1 over cosine, and cosecant is same as 1 over sine theta. Okay. So then let's rewrite this. So here we can think as sine theta over cosine theta plus cosine theta over sine theta. I'm writing the numerator. Dividing by this is same thing as multiplying the reciprocal. So we can multiply cosine theta times sine theta over 1. So that means we have to distribute this both sides, and that's what we get. So when I multiply this to right here first, we have this cosine and this cosine will cancel out. So I just have sine squared theta. Plus, when I multiply this one with this, sines will cancel out with cosine squared theta. And by Pythagorean trig identity, this equals 1. So we just verify this is left and right are same expression, equivalent. Part C. Again, pause the video, try on your own, then come back. So let's try. So here we have to pick which one we think is more complicated. Okay. So I think this is more complicated. But again, if you choose this one to be more complicated, that's fine as well. As long as you can verify, it doesn't really matter which one you start with, but more complicated side is easier to work with. So let's rewrite secant as 1 over cosine of x. Tangent is sine, not theta, sine x over cosine x. Okay. So we can rewrite this as 1 plus sine x over cosine x, since cosine is the common denominator. But we, on the left side, we have 1 minus sine theta, sine x as a denominator, right? So to make it look like that, we're going to multiply 1 minus sine x over 1 minus sine x top and bottom. So this is called, sometimes we call this fancy one. We're multiplying essentially 1. So it doesn't change the quantity. Okay, so let's see what we get. Then we get, in the top, we get 1 minus sine x times 1 minus sine x. The denominator, we get cosine x times, again, keep the parenthesis, sine x. So we're going to multiply these out. So this right here, let me underline this. This has that form, or this is plus here, of that a plus b times a minus b equals a squared minus b squared. So following that, we just have 1 minus sine, well 1 square, but 1 square is same as 1, sine square x, over in the bottom we have, we can just leave it as cosine x times, we don't have to multiply that out. So then now let's look at this part, right? This part should give us somewhat of indication that we have to use a Pythagorean identity of sine square x plus cosine square x equals 1. Then if I subtract sine square both sides, I get cosine square x equals 1 minus sine square x. So here, since cosine square x equals 1 minus sine square x, I'm going to replace this with cosine square x. So then I get cosine square of x divided by cosine x times 1 minus sine x. Now we can see that one of the cosine cancels with the bottom one. So what we have left with cosine of x over 1 minus sine of x, which is what we have here. So we're able to verify left and right side. Again, please don't feel discouraged if you don't get it right away. This takes practice to build intuition, to know what to do, what to multiply, to verify. Okay, so let's look at this. Find exact value. Okay, so then again, if this angle were to be a unit circle, we could just get the value from unit circle. But pi over 12 value is not on unit circle. That means we have to find two angles that we can add or subtract from each other to obtain pi over 12. So we have to use one of those sum and difference identities. And those identities will be given on the quiz, so you don't have to memorize those identities. So first, let's try to break down pi over 12. Okay. So just looking at pi over 12, it might not be as intuitive. So one other way we can do it is we can first convert pi over 12 to degrees. Multiply by 180 over pi. Cancels out, cancels out. Then we'll get 15 degrees. So pi over 12 is equivalent to 15 degrees. Then from unit circle, find two angles that we can add or subtract to get 15 degrees. And there are many choices. 60 minus 45 or 45 minus 30, any of those are fine. So I'm just going to choose 45 degree minus 30 degree gives us 15 degree, right? So this would be my A and B. Okay, so you can work with degrees because in the end we'll still get a same answer. Okay. Or we can also just write A as pi over 4 and this is pi over 6. So that means that pi over 4 minus pi over 6 will give us pi over 12. So we can rewrite cosine pi over 12 as cosine of pi over 4 minus pi over 6. So the reason why I convert to degree is because it is more intuitive to come up with these two angles. I can understand that if we cannot right away tell what two angles in radian, we subtract to get pi over 12. But by converting to degree, it helps us to find these two angles more efficiently. So then here we have to use one of the identity. So let me write the identity. This is cosine A minus B. So we have to use cosine A minus B. Again, this will be given in the quiz, so you do not have to memorize. Cosine A minus B is cosine A times cosine B plus sine A sine B. So applying to here, we have A is pi over 4. So we're doing cosine of pi over 4 minus pi over 6. So we have cosine of pi over 4 times cosine of pi over 6 plus sine of pi over 4 sine of pi over 6. So as you can see, the knowing unit circle is very important because now we can find all these values from unit circle. But if you have not memorized, or if you cannot construct unit circle on your own, we cannot evaluate these answers. So make sure you review those, all the concepts from module 2, including unit circle. So let's write one at a time. Cosine pi over 4. Cosine pi over 4 is square root 2 over 2. Cosine pi over 6 is square root 3 over 2. Plus sine pi over 4 square root 2 over 2. And sine pi over 6 is half. So we have square root 6 over 4 plus square root 2 over 4. And our answer is just square root 6 over square root 2 over 4. This is as simple as we can make it. Okay. So when it's cosine A minus B, this is the formula we use. And it is plus, so keep that in mind. It's not a mistake, that's just the identity. And we did not talk about why this identity work. Right? There's so much you can cover in this class. So for this identity, you need to be able to use it. Use it and know when to use it. When do we use it? When we have an angle that is not a unit circle. Okay, so let's look at 3. Again, try on your own and come back. So here it says use cosine 2 theta. Okay. So cosine 2 theta has 3 equivalent identities. This is called double angle identity. And this angle also will be given. Okay, it will be given on unit circle. So they give us a sine theta equals 4 over 5 between 0 and pi over 2. That means that in the unit circle of a first quadrant, there is the angle is somewhere here. That's what they're telling us. Okay, and 4 is the vertical distance, right? So this 4 is right here, and 5 is radius. There's radius. Okay, so then we can't find this length. This is theta. We can find this length using Pythagorean theorem. So 5 square equals 4 square plus, let's call it x square. If you solve for this, x is, you will get plus minus 3, but because it's in first quadrant, we only look at positive 3. So this length is 3. So if this angle were to be on the second quadrant, then we'll get actually negative 3, because cosine value is negative in the second quadrant. So now looking at this, now we can actually find what cosine theta is. Cosine theta, we can see that is 3 over 5. But the question is asking cosine 2 theta. Right? So cosine 2 theta has, again, 3 identities. Again, this will be given in the formula on the quiz. Cosine 2 theta equals cosine square theta minus sine square theta, or 2 cosine square theta minus 1, or 1 minus 2 sine squared theta. You can use any one of these to find cosine 2 theta in this example. So here I'm just going to pick this one. So then, again, if you can use any of these to find, they all give you the same answer. So let's use this. I know that cosine theta is 3 over 5. So if 2 times 3 over 5 square minus 1. Because cosine square theta means cosine theta entire thing square. This is the same as cosine square theta. And we know that we just found the cosine theta is 3 over 5. That's why I'm squaring it here. Then let's just simplify. We have 2 times 9 over 25 minus 1. 18 over 25. 1 is same as 25 over 25. So our answer is negative 7 over 25. Okay. So get number 4. So again, try on your own, then come back. So number 4, on the figure below, sketch a terminal ray of angle that has a sine value of negative 0.2. So the fact that they're asking us to sketch terminal of angle, that means essentially to sketch an angle. That will give us sine value of negative 0.2. So again, make sure to review definition of sine, cosine, tangent from module 2 if you forgot or if you're not familiar with it yet. Sine measures vertical distance from horizontal diameter from the terminal ray using radius length. So vertical distance, so negative 0.2. So let's say we can just say that, okay, let's say the radius is 1. Okay, so I mean this length is also 1 here. Okay, this is also 1. And since sine is a vertical distance, we can think as, okay, maybe this distance, this right here is about negative 0.2. And what is the angle that gives me negative 0.2? Is this angle right here. Okay, so this is the angle. They'll give us negative 0.2. And we can also actually think this angle as well. Okay. But that's why it is asking to just draw a terminal ray, not necessarily the angle. Okay. Because these two are actually coterminal to each other, right? So this is one answer right here, this line right here. Can you think of another answer? They'll give us vertical distance negative 0.2. There's also, we can think as here's a horizontal diameter. This direction as well, right? Negative 0.2. And this angle. This terminal ray. This distance right here is negative 0.2. From the horizontal diameter to the angle, to the terminal ray, this distance is negative 0.2. Okay, so we have possible 2 answers here. Okay. So this is important. This is important because first we get to review what sine is, but when we talk about inverse sine or arc sine, again, arc sine must give us only one answer, but arc sine is dealing with, okay, this is the output when this is the input. So if this is the input, when this is the input, what is the output? Output is this angle right here. Okay, again, this angle is not a unit circle, so we cannot express it numerically without a calculator, but we can still do, this is the output, this is the output right here, this angle right here, whatever the angle is in the measurement of radian. Okay, so that's why we call it arc sine, because it gives us the arc that gives us sine of this value. An arc measured in radius length is the angle in radian. It means the same thing. So let's build up on that and try this problem. Okay, so I'm going to do A and B. Then I'm gonna suggest you to pause the video and try C, D on your own. Then you can come back and check your answers. Okay, so use a diagram to estimate arc length, measure in radius, unit of radius length. Again, that is the angle in radian, right? That produces the following sine value. So an arc length, okay, an arc length of what will produce 0.5, okay, of a sine value. Okay, so 0.5 is right here, sine. So here's 0.5 right here. So what's the corresponding arc length? So start from here. Where do I meet that right here? So we just need to count. We need to just measure this arc length, measure in radius length. But since radius is 1, we just divide by 1, which is the same answer. So here we just need to count this. This is about 0.1, 0.2, 0.3, 0.4, 0.5, maybe about 0.55. So I just literally just count this arc length, because from here to here is arc length 1. So we get to this mark right here, which is 0.5, and went maybe halfway between 0.5 and 0.6. So this arc length was 0.6. Oh, sorry, 0.55 about. Right, that's where they meet. If I were to draw again, this is the angle. We can also think is this is the angle, this is the angle. Again, this angle and this angle is same thing, right? Same measure, same amount of measure. This is the angle that will give sine value, this value of 0.5. Measure in radius length, so we divide by 1. So this divided by this gives me 0.5 divided by 1 gives us 0.5. Okay. So let me erase this since I'm going to do another one. But I think it is also productive to just think as this is distance. What is the arc length created by this? Okay, that's one way to think about it. So now we're going to sine value of 0.7. So let me use different color. 0.7 is here. So here is 0.7. Okay. So what is the arc length? Okay. We're just counting it, right? From here to all the way, maybe somewhere here, little less than 0.8. Right, so this is 0.8, 0.9, 1. So this is maybe 0.78. Again, we're just estimating, so 0.78. So this angle right here, will give us sine value of 0.7. Okay. So again, I hope this helps you visualize how inverse sine or arc sine is working. Okay. So try C and D on your own, right? Then come back. Let's just raise it for the. Okay, so negative 0.3 is right here. Okay, negative 0.3. What is the corresponding angle? So 0.3. Again, if you pay attention, if you go close, no, let me do it again. Start from here. Oop. Negative 0.1, negative 0.2, negative 0.3. So maybe it's a little more than negative 0.3, but again, we're just estimating, so let's just write negative 0.3. Or if you write negative 0.31, that's fine too, because we're just estimating. The important thing is you understand the steps, what we're doing. This is the input, this is the output, right? We're dealing with arc sine right here. So about negative 0.8. You see the pattern by now. Negative 0.8 is right here. If this is input, what is the output? Output just measure all the way until this length will meet this arc length right here. So this right here, this arc length. Well, let me highlight it. This arc length. Okay. So again, we're going clockwise, which gives us negative angle. So that's why we have negative. So let's say this is negative 0.7. So this is maybe negative 0.63-ish. Again, if you write 46465, again, that's fine because we're just estimating. But just try to visualize what's going on, right? So this is how arcsine is working, okay? So then let's try to find its exact values. Now, when we ask you to find exact value in inverse, sine, cosine, tangent, all these angles, all these values, input values, and the output alpha value, which are angles, are from unit circle. So keep that in mind. So arcsine of square 3/2. So they're asking, essentially, on the unit circle, what angle will give me square 3/2? But we must remember, this is actually implied between angle between negative pi/2 and positive pi/2. So answer must be only one answer. So they're only asking essentially this angle right here, this arc length on unit circle. So a unit circle right here, they're only asking this portion of angle. They will give this height. Okay? They're not asking for this one. We restricted to this for the sine, only the negative pi/2 to positive pi/2. So then you go to unit circle, then it will tell you that the answer, the angle, right? So answer should be angle, is pi/3. So this angle is pi/3 on unit circle. Sine 0, sine inverse of 0. So this is the height, that angle is just 0 right here. So let's look at sine inverse of negative square root over 2. So now we're going negative, so we're going this direction on unit circle. So it will be right here. Okay. What is this angle? So then if you go to unit circle, the angle will be shown as 7 pi/4. But 7 pi/4 is not in this range. So we have to write this angle in negative. So we have to start from here and go this direction. So then this amount of angle is actually pi/4, negative pi/4. So this is actually negative pi/4. So if you write 7 pi/4, that is incorrect. Although they have their coterminal angle, in sine inverse, cosine inverse, and tangent inverse, it is important to pay attention to this range. Is already fixed. So when we do this problem, it's implied that you must consider this. So this comes with it, although it's not written. So you must remember this. Oops, sorry. Now for cosine, range is also different. Cosine range is 0 to pi. That means we look at top half of this unit circle. So when it asks arc cosine of negative half, cosine is asking horizontal distance. So this is this distance right here. Okay, and so what is this angle? That's what they're asking. So they're asking, in this case, this angle right here. Okay. So for cosine, what is that angle in unit circle? Again, knowing unit circle is very important, as you can see. Okay. So cosine of negative half, the angle will be 2 pi/3. And how about this? Square 3/2. That's positive square root over 2, 3/2. So it's this angle right here. So it will be pi/6. Again, please pay attention. All the outputs are angle or arc length. That's why we call it arc, which is also the same thing as sine inverse. Now arc tangent of 1. Remember, tangent gives a slope. So this value right here represents slope. So what angle will give us slope of 1? That's the pi/4 right here. This is the slope. Because for tangent, the range is also negative pi/2 to positive pi/2, just like sine. So we're finding this angle only right here. Let me maybe use different color. So for sine is asking, what is this angle? That will give us slope of 1. Okay. That's pi over 4. Negative square root of 3. Okay. Slope is negative, so angle must be in this area. Okay. And it will be this one right here. Okay, because on unit circle, let me just write it. On unit circle, it is written that it is half, comma, negative square 3 over 2. So for this one, if I find tangent of this angle, tangent of this 5 pi over 3 will give me sine over cosine, give me negative square 3. But that does not mean that the answer is 5 pi over 3, because answer must be between this range. So we have to write this angle in negative, this direction, which is negative pi over 6. Negative pi over 6. Okay. So remember, as I talked about in the main lesson video, it is very important to pay attention to this range when we're evaluating sine inverse, cosine inverse, tangent inverse. And for all the inverse evaluating, there's only one answer, as you can see here. One angle. Because it is a function. So let's look at this. If a loading ramp is placed next to a truck, height of 4 feet, so this is an application of inverse trig, height of 4 feet, and ramp is 8 feet long. 8 feet long. What angle does ramp make with the ground? So what is this angle they're asking? Right? What is this angle? Or what is this? We can also, again, this angle is same as this angle, or we can also write it like this angle, right? Okay. So if you think in terms of right triangle, yeah, we can just set up sine theta equals 4 over 8, which is half. Sine theta equals half. But if you find sine theta in general, if you want to find this angle in general, there's infinite number of answers, right? Because there are infinite number of coterminal angles, right? That will give us half, sine of half, sine theta of that half. And even in unit circle, there are two angles will make this true. So we get pi over 6 and 5 pi over 6 will give us this theta. Okay. And because this is acute angle, yeah, answer is pi over 6. But if we just think in terms of arc sine of half, it will automatically only give us this answer. Okay, so answer is pi over 6. Okay. So we need to be able to think in terms of the context of the problem. Yeah, we can just find arc sine here, arc sine of half, because it will give us this acute angle. Or if you do this, then you have to think about the range of this angle. Is it really possible to have 5 pi over 6 between the ramp and the truck? Or ramp and the ground? Okay. Something to think about. Moreover, is it even possible to have angle 2 pi plus pi over 6, right? So nice thing about arc sine, arc cosine, arc tangent, it only gives us one angle. Okay? And sometimes that one angle is not good enough, but in this case it is good enough because this is acute angle. So now we're going to look at solving trig functions. So here we have 2 sine square x plus sine x minus 1 equals 0. So here we have quadratic form. So actually, in order to solve for 0, we need to factor this. So way we can think about it is, let's let sine x equal to be capital A. So I'll rewrite it 2 times a squared plus a minus 1 equals 0. Now the reason we do this is now, since we have a variable of a, it seems easier for us to factor. So we have 2a a equals 0. So let's see, would it be plus here? actually minus here and plus here. Okay. So I just factor this quadratic like this. You can also use quadratic formula if you prefer. So why do we do this? Because then we know that in order this to be 0, either this has to be 0 or this has to be 0. Okay, by zero product property, right? Anything times 0 is 0, right? So we set this equal to 0 and set this equal to 0 and solve it. So we have two equations to solve for. 2a minus 1 equals 0. And we also have a plus 1 equals 0. 2a minus 1 equals 0. We can solve for a is half. And here a is negative 1. But what was a? A was sine. So plug sine back in. Here we have sine x equals half. Here we have sine x equals negative 1. Now we have to find angles, angle measure x, such that angle is between this range. That will make each of these statements true. So then, again, this is different from solving sine inverse. This is find angles that will give us sine of that angle half between this range. Whereas in sine inverse is implied that between negative pi over 2 and positive pi over 2. So then we go unit circle and find the angle that will make this true. Okay. So we have pi over 6 and 5 pi over 6 for sine of that angle equal half. For sine equals negative 1, we have only one angle, which is 3 pi over 2. So this equation has this solution has three parts: pi over 6, 5 pi over 6, and 3 pi over 2. This is the solution. Any of these three angles will make this equation true. Again, pay attention to this restriction. If this was not given, we have to add 2 pi k to each of these answers to show that we can use any of the coterminal. But because it gives us restriction between 0 and 2 pi, we only find these three answers. Number 9, again, try on your own. Pause the video, try on your own, then come back. So generally when we solve for trig, we want to have trig expression by alone. But number 8 was not like that because we have to factor. Okay. So here we have to just put cosine 3x by one side equals divide by 2 both sides. I get negative square root 2 over 4. So then we have to find, angles that will give us negative square root 2 over 4. But actually, negative square root 2 over 4 is not on unit circle. Okay. So I'm actually going to change this problem. Let's make it a little simpler for us. So let's say 2 was not there. Oops. So suppose problem was just this. Okay? This is just a problem between 0 and 2 pi. So don't worry about 2 here, because actually it's not possible to solve with 2 there using unit circle. Okay? So let's just look at this. How do we solve this problem? Okay? So here we're finding angles that will give us this. So first we do have to find what 3x has to be on unit circle. So what are the angles? So what are the angles that will give us negative square root 2 over 2 on unit circle between 0 and 2 pi? So 0 and 2 pi is essentially from unit circle. So list all these angles. Okay. So we get 3 pi over 4. And we also get 5 pi over 4. So these are the two angles that will give sine of this angle. This angle will give us negative square root 2 over 2. Okay. So that means that 3x must be 3 pi over 4 and 3x must be 5 pi over 4. But we're solving for x. So for here, divide by 3 both sides, we get x equals actually pi over 4, one answer. And for this one, divide by 3 both sides, we get x equals 5 pi over 12. So these two are the answer for this problem. So let's look at this. Again, here we want to have trig expression in one side alone first. So sine square x equals 1 over 4. Since it's sine square, I'm going to take square root both sides, which makes sine x in one side, and right side will be plus minus square root of 1 over 4. So then let's rewrite it. Sine x equals plus minus square root of 1 over square root of 4, which is same as plus minus 1 over square root of 2. Oops, sorry. Just 2. So we're finding all the angles that sine x equals plus minus 2. That means that we actually have two equations. Sine x equals half, sine x equals negative half. So now find all the angles that will give us sine of that angle half, sine of that angle negative half from unit circle. Well, actually it doesn't say 0 to 2 pi, right? So that means we have to add 2 pi k for each of these answers. Okay. So this problem has infinite number of solutions. So sine x equals half. So first, do find from unit circle. So pi over 6, and 5 pi over 6 will give us sine of half. And how about negative half? Will be 7 pi over 6, and this will be 11 pi over 6. So we found just 4 answers. So if there was a restriction, these 4 would be the answer. But since there's no restriction, we have to add 2 pi k. K is just integer. 2 pi k plus 2 pi k plus 2 pi k. So 2 pi k is just adding or subtracting full rotation to indicate all the coterminal angles. So these 4 expressions is a solution for this problem. But in terms of number of solutions, there are infinite number of solutions. Okay. So as I said, make sure you know how to construct unit circle on your own, and be familiar with it because you need to be able to use those values.